before we start, let me introduce myself. I am Lovely Munjal. I have been working in ThoughtWorks from last close to 3.5 years. And if I talk about my overall experience, it's around 7 years in the industry, worked on different kind of applications and involved in different kind of testing. Yeah, that's brief about me. We have co-speaker with me. Yeah, Pravina, over to you.
Sure. Hello everyone, my name is Praveena. I have about 15 years of industry experience. I am a software developer and been with ThoughtWorks for around 3 years now. Yeah, that's about me. Lovely.
Yeah, thank you. I'm glad to see large number of attendees and count is still increasing. And okay, let me start. So what you can expect from this talk? Yeah, you can see the content on your screen. So in this 90-minute talk, we are going to share about our practical experience and knowledge, what we gained from one of the project by working on the autonomous vehicle. We'll start with the introduction and then we'll move to functional architecture because that is very important before we move to testing part, right? So once you know the application, how it is built, you can test the application. We'll talk about middleware technologies used in the AV because every AV product is not started from the scratch. So there are some standard middlewares as well. After that, we will move to demonstration part using ROS and followed by the test strategy for the autonomous vehicle. Testing part, we will cover around 60% of the talk. That will be around more than 40 minutes. And complete talk will be technical and there will be a little bit theoretical part, like you can expect around 15-20 minutes, but most of the things will be technical. So if you are beginner in the AV domain or even if you are at intermediate level, then this talk is for you. You will come to know something new. Yeah, that's brief about the content. Pravina, over to you. You can share your screen.
Yeah. Okay, I'm hoping that my screen is visible.
Yes.
Yeah. So now that Lovely has set the context, here we are going to talk in this talk, we are going to discuss autonomous vehicles as a generic topic domain. We are not going to talk about specific vehicles. We are going to give a brief introduction on what does autonomous vehicle mean, what does software components of autonomous vehicle would look like, and how would you go about testing that. So I will start off with asking a basic poll. So we'll just quickly throw a poll, company. So you will see a poll in your screen. Can you please, attendees, go ahead and answer that? Okay, so the reason behind this poll is for us to, as presenters, to understand the mix of audience that we have today. Yeah, once we have the results, we'll progress into the slides. Okay, so Kamini, can you present the results? Okay, great. So this goes to show that you guys are going to learn a very new topic. This is we have a lot of people with no understanding on this. That's a good valid input for us. So what is an autonomous vehicle? A vehicle which drives by itself is an autonomous vehicle. So such vehicles are not just commercial mobility vehicles like cars and trains. It's also these vehicles, specialized vehicles, which are used in mining industry and warehousing industry and so on. There is no depth of usability for autonomous vehicles. So what are its benefits? So there are proven results from having autonomous vehicles on road. We know that the accident rates have drastically decreased in standard test environments. There is a high utilization of the roads. So there is no traffic congestion because of this, because of course, vehicles are able to make these precision decisions much faster than humans. And of course, since these vehicles provide fuel economy, there is a lot of improvement in our atmosphere too. So these are some of the benefits. Like I mentioned before, autonomous vehicles are not just in roads; they are also in multiple other areas where the productivity is increased manifolds because of such autonomous vehicles. Okay, so I'll move on to the levels of autonomy. So basically, the Society of Automotive Engineers define 6 levels of automation in the vehicles. That starts from level 0 and it goes up to level 5, and with increasing order of automation the levels increase. So basically, level 0 vehicle would be a manual vehicle with very limited supporting driver supportive functionalities, and level 5 vehicle would be a completely autonomous vehicle which is capable of driving itself from starting point to the ending point without any human intervention. So that's the level as defined by the SAE. And if we see that that these we are talking about autonomous automation levels in in a in a running vehicle. So for example, if we take an example of cars, we see these manual vehicles to be the ones which has no support systems. Say level 1 vehicle would be something like a car which has adaptive cruise control, which basically means that the car notifies the driver that there is a vehicle ahead and that you should slow down, but the vehicle the software does not take control of the vehicle, so the vehicle cannot be steered by the software. And then when we move on, these partial automation vehicles, level 2 vehicles, are the ones where it's not just notification given to the driver, but the vehicle is also able to maneuver itself to the next lane and so on. So such as the capabilities of level 2 vehicle. And then when we move to the third level vehicles, right now in the market, level 2 autonomous vehicles like Tesla's autopilot is already there. So we are looking at fully autonomous vehicles in our roads in the really near future. So likewise, if we go to level 3 and 4, there is subtle improvements into the automation levels of the vehicles, but it's not so much that is really visible to the human eyes. The prime focus here is to make the drivers take his hands off of the steering wheel. So at level 5 automation, there are no steering wheels in the car. So if we are, while talking about this from consumer vehicles point of view, the cars won't have steering wheels. It's completely autonomous. People just go sit in the seat, and then the vehicle starts and it takes you to wherever you want to go. So that's the level to which automation is going to grow in the near future. And many of the companies, big players in the market, are currently eyeing for level 4 and level 5 automation. But higher the automation level, higher is the governmental requirements and standards and guidelines. So those are some of the things that that is needed to be dealt with by vehicle manufacturers. So we have just listed out some of the current situations. So one of them, for example, it is so interesting, right, to be able to get into a car which is a taxi and it's driven by itself. You don't have to do anything. You just open the door, sit in the car, vehicle starts and goes off by itself. And that is not that is a reality right now. There are shuttles in level 4 shuttles in the US where the vehicle drives by itself and can reach a top speed of 55 miles per hour. And these vehicles are also capable of self-driving and also be tracked so that everyone is aware of where a certain car is present. So that's what we are looking at. That's the latest trend in this market. Okay, so I will take a pause and we will just get on with the next poll. Kamini, next poll, please. So this is a generic question with whatever we discussed so far. Any ideas if we have any level 5 vehicles on roads now? Okay, when you're voting against this poll, let's just move on with the discussion on the hardware and software requirements for this autonomous vehicles. So autonomous vehicles, there are two prime components to a vehicle being autonomous. They are the basic hardware requirements that the vehicle has and the onboard software on the vehicles. So both these two go hand in hand in making the vehicle fully autonomous, right? So yes, you guys are right. Yes, there aren't any level 5 vehicles on road right now, but lots of testing is in progress. Much to come in the near future. Okay, so we have just listed out couple of or few of hardware components. One of them is LiDAR. LiDAR is nothing but a light detection and ranging system. Basically, by sending laser waves, vehicle in the front is identified, like how you would just use sonar, where sound waves are sent out, broadcasted, and the reflected images or reflected light waves are taken up and processed. That's a LiDAR device, which is a very expensive device. And cameras, typical cameras, these are to use to do image processing. So these cameras capture images. These images are processed by the onboard software, and useful information is obtained from these camera and LiDAR information. So that brings us to the most important part of autonomous vehicles, which is the navigation system. So if I'm a human being, I want to travel from point 1 to point 2, what I would do, I would first identify the path that I want to take. I would look around, see how the road conditions are, see what are the vehicles that's already on the road, and then I will start my vehicle, get onto the road, and then navigate the traffic and slowly move into the to the path that I want to go, and then reach my destination. That's all. That's what I as a human being would do. Now, if I want to do the same thing as a vehicle, what should the vehicle be doing? What it does is it first captures the camera view, which gives this image. This is a raw image, and then this is from the camera. And now we also have LiDAR, right? So LiDAR gives light, broadcasts light wave and gets rough images. These are called as point clouds. Now I have a camera view now and a LiDAR view. I just have to fuse it together to make meaningful information out of it, right? So that's what is called as sensor fusion. So there is a camera view, there is a LiDAR view. Combining them together, I get an information that there is a vehicle in front of me, or there is a pedestrian in front of me, or there is a static obstacle in front of me. So why do we need two different sensors for doing this? A camera is a relatively cheaper hardware, but a LiDAR, it's very expensive, right? So the more sensors that we have in a vehicle, the costlier the vehicle would become. But there is a reasoning behind having multiple sensors. A camera gives a two-dimensional image, so I cannot really gauge what is the distance between these two cars with the camera view. But LiDAR is capable of giving us the distance, so I can tell that this vehicle is 100 meters ahead of me. But LiDAR falls short in certain things, like it cannot detect color. Say, for example, if I'm interested in knowing the signals, is it a red signal or a green signal, I cannot do that with LiDAR. So I would need a combination of these two to give me a valuable information that would enable me to identify the vehicles in front. So now I see that there's a vehicle ahead of me. So what does the software do? It identifies a path trajectory and tells the vehicle to maybe switch lane and then overtake this vehicle, because there's a slow moving vehicle in front of you, and then go ahead. So this sort of combination of software is what we are looking at in as part of autonomous vehicle navigation. Now that we know these are so many software components, we need a way for these software components to work together, right? And um, so I mean, before that, let's get on with the functional architecture. So now that we know that I get these sensor views, say camera view and the lidar view, those are what is called as perception. So now I get these two views, I combine together and I perceive an environment around me. That's perception module in the software. And what does that do? It helps me plan a path or validate my path accordingly. And after a path is planned, what does that software system do? It sends out a message to lower layer saying that, you know what, steer the vehicle to the left. So that's a notification given to the lower layers in the architecture. And once the control gets to that level, our autonomous vehicles don't really go and change the or steer the vehicle or apply the brake. It tells the hardware layers that press the brake pedal, or press the accelerator pedal, or turn the steering wheel to the left and right. That sort of actuation is done by the hardware modules. So we earlier spoke about hardware. These sensors give me input, the software perceives the input, finds a path, sends out control messages, and then what does it do? It tells the hardware to do the control operations that the software wants the vehicle to do. So this is how a typical autonomous vehicles architecture would look like. So it's not just software, it's not just hardware, it's software and hardware. A combination of both is what makes this a unique system. Now let's move on to the common technologies that we use in this area. So the language, as you can see, we have put up a list of technologies that are in use. C++ is the most common language that's used, mainly because it is way more easier to manipulate hardware from a C application or a C++ application over highly developed languages, because C++ and C overrides all of the bulk that you get with higher level languages. So in our demo, we are going to show you how to set up a autonomous vehicle development environment using C++ and ROS as the middleware and the OS as Ubuntu. And now moving on to the middleware, we are going to talk a little bit about ROS because ROS is one of the middleware that's commonly used. When we get to ROS, I will explain a little further on ROS. But in our demo, we are going to talk about ROS, and the environment is set up on Ubuntu. So ROS here is not it stands for Robotics Operating System. It's not really an operating system, but a middleware or a networking layer that ensures that all of these components that we saw, these software components we saw earlier, works together. So it basically ensures that networking system is set up well in there, and so that the nodes are always talking to each other. So, or the software components are always talking to each other. Okay, so moving on. So why do we need a middleware? So the most important aspect of an autonomous vehicle system is that the processing has to happen really quickly, because we only have a couple of milliseconds time between a vehicle goes and say dashes on the vehicle ahead of it, right? So speed is of paramount importance here. Our software has to be really quick. The algorithm should be highly optimized so that everything happens in real time at high speed, right? So ROS is one such middleware. It is that networking layer. It is built on TCP protocol. It is not built on HTTP, because we are not talking about networking between a physical device and the internet. We are talking about networking within a certain specific hardware. So ROS fits the bill. It provides the needed networking environment to have all the moving pieces working together. And ROS is a general purpose open source software. It supports the biggest advantage is that it supports C++ as well as Python. So what does that mean? It means that in ROS, you can write software, these components that I mentioned, say for example, planning software in both C++ as well as Python. Of course, people don't prefer Python because it is not as close to the hardware as C++, but still the ability exists. And ROS also comes up with a whole set of packages. For everything, there is a package. You want to represent something in ROS nodes? Yes, there is a package. You want to represent your path as a map, there is a package. So it comes with a lot of packages or pre-built packages, and it also has a lot of convenient developer tools. Plus, of course, for robotics, we need visualization and simulation, because we can't really take our vehicle on test drive daily, right? So we need visualization and testing environment. So ROS also comes with all that by default. So that takes me to the demo. Okay, so let me quickly move on to the demo. Okay, so we have already, we'll share the GitHub URL with you all. We've created a sample ROS project, which you can just clone and take a look. We have a good set of prerequisites, and the README is verbose, so it contains all the information that you would need if you want to start off as a robotics or ROS node tester. So the first prerequisite is that you set up a Parallels or any VM virtual machine which runs Ubuntu, and on that you will have to install ROS. And so you can the steps to install ROS is listed here in the ROS website. You can take a look at that and spin up Ubuntu VM and install ROS in there. So in our test environment, we are using Catkin, or even in general in ROS also, Catkin is the preferred make system. So build system is Catkin make. So when you just download or install ROS and run these sets of commands, you would get an empty workspace or a bare bone workspace, and then you're ready to go. The coding can start off right away. You just create the Catkin workspace, and then in that you create a package. In our case, we have created a package called as ROS demo, which is what you see here. This is the name of the demo, the name of the example. So after you create the ROS demo package, what you would get are the package.xml file, which is nothing but a configuration file for the Catkin make, and then the CMake list, which tells us the build commands, or which sets up the build command. And you can create, the include and SRC directories are already created. It would be empty directories. And then once you set this up, you can just go ahead and create your own source code by creating files under the SRC directory. You can, like I mentioned earlier, you can create Python files, you can create CPP files, up to the developer's preference. And in the ROS world, every running entity is called as a node. So a node is the background application which would spin itself up and wait for notifications. So there are two ways that communication can be established in ROS. One is through topics, where a publisher would say that I want to publish to a topic, and would publish to a certain topic, and a subscriber node would launch itself and subscribe to topic, and every time it receives a message on a topic, it would respond to that topic. So that is one way. There is another mechanism called as services. We are not going to talk about services right now. We are going to only talk about topics. So a simple publisher node takes just four or five lines of code to start off. So here in this CP file, you'll see that I've created a node by the name publisher, and this publisher node says it will publish to a topic called as topic 1, and there I've just written a simple while loop where I'm going to just publish hello world followed by some number every second. So it's a never ending while loop. So it just prints out this message. So let's quickly see how do you run these things up. So this is a fresh new environment. I do not have, I only created these publisher and subscriber code files. So how do I build this? All I have to do is run catkin make.
Can you please zoom a little bit?
Lovely, I couldn't hear you.
Can you please zoom in a little bit?
Okay. No. How do
Control plus or Control Shift plus?
no. Yeah, Control Shift plus. Yeah, sorry. Yeah. Okay, so is it visible now, Lovely?
Yeah.
Okay, so I just built this software. Let me go to the top of the screen. When I list out the files, there is a directory by the name DEVEL, Devil directory. It is the build output directory, and build is the build intermediate directory where intermediate files like obj files or .o files get created. In the Devil directory, you would find the executable. In our case, there would be an executable by the name publisher, and there would also be an executable by the name subscriber. So let's check if those exist. So Devil. Okay, Devil lib ROS demo, and you can see that I created created two new executables called publisher and subscriber created just now. And now if I want to run a publisher, I will have to run up something called as run something called as ROS core. So what does ROS core do is to spin up a master node or a background process which ensures that the communication between the publisher and the subscriber happens. So no two nodes talk to each other directly. They talk only through the ROS core, which is the master node. So I've just started off the master node. I am going to now launch the publisher node. Demo. I'm going to just launch the publisher node. So this publisher node is just publishing some messages. So when I do a ROS node list, it tells me that there is a publisher by the name publisher. Let me just stop this node and let me run the okay, is this clear? Yeah. Okay, so I'm going to just do ROS node list. You can see that the publisher node stopped and there's just one node running. So now if I want to see what were the topics to which some node was publishing, I can just do ROS topic list. Right now you won't find anything because the publisher node is not running. So if I were to rerun the publisher node and look at the topics, you can see that a topic by the name topic 1 is advertised by some node that says it's going to publish to topic 1. So I can also do ROS topic info to get more details about our topic of interest. In our case, topic 1 is there is a topic called topic 1 to which the node publisher is publishing. Right now there are no subscribers. If I spin up a subscriber node, I will also get the list of subscribers. So I could just spin up the subscriber here. Subscriber. So subscriber is just printing out whatever it is hearing. So if I do ROS topic info, I can see that there is a publisher node which is publishing, and there's a subscriber node which is subscribing to this node. And with that, I end my demo. I will take a quick pause and let Lovely continue after this. In the meantime, Lovely, can you take over?
Yeah. And if you have any questions regarding ROS, you can ask in the Q&A. Let me share my screen. So you have seen, right? So ROS is basically providing the communication layer between various nodes. And why would we need communication layer? Because if you see normal application like a normal website, which is handling traffic of very large number of users, they are not using any middleware. They are using just HTTPS call, right? But in AV, actually, we would need very high performance system. And for that, we cannot rely on HTTP or HTTPS. If you know like how HTTP works, it basically works over the TCP. And ROS is also working on the TCP. It's very fast, and we can send the data through ROS topics. A topic is like a bus, and data is like passengers on the bus. Okay, so through these bus we can send any data, but the condition is like that ROS master should be up, like Pravina mentioned. She started using ROS core command. So this is the reason of not relying on very REST APIs or HTTP, HTTPS like in normal software products we see. That's why in AV we would need, of course, every time a middleware, because otherwise people will have to write all these things from the scratch. That is very difficult, you know. And we'll move to testing part. But before moving to testing part, um, let's have 2 minute break. If you want to take 2 minute break, we will back at maybe 3:43. So it's 3:41 right now. Let's have 2 minute break. But if you have any question, we are checking the Q&A chat. You can ask.
I saw a couple of raised hands. So if anyone has any questions, please use the Q&A. We'll be answering those there.
And someone was asking about prerequisite. In README, we have mentioned everything, each and every command. So don't worry about the coding part. You will get the GitHub repo as well. And I'm using for this Ubuntu VM. I'm running Ubuntu VM on my MacBook using the software Parallels. You can also use Parallels, but it is paid. So if you want any free software, you can use VirtualBox. There you can easily run any VM. Even on Windows as well, you can start your Ubuntu VM. Okay, so Ubuntu OS, Linux-based OS are very fast as compared to others. So in most of the embedded system, you will see these operating systems. Let's wait for 30 more seconds. Okay, people, let's start with the testing part. So basically, like we know in this product, a lot of hardware is also involved. That's why testing will be a little bit different from normal software products, but the basics will be same. Okay, so like we have test pyramid, the way we test normal applications. So the same way we have drawn our test pyramid here. We'll start from the bottom layer, that is our unit test, which are very lowest level of test, you can say. Like Parveena has shown you the node, and node was running like publisher, subscribers. If we want to test these nodes, then that will be comes under unit test, right? We don't need to test the complete system. We just can test the ROS node only. And let's say if you are using any algorithm to find the path, or for any motion planning or anything like on the road, there is some obstacle. So whenever there is any algorithm used, you can test that algorithm separately as well, right? And when the things are combined, like various nodes, various publishers, subscribers, all these nodes are combined, then you will have to start all these nodes together, right? And then you will be running the test. Like one node is sending some topic, another node is receiving. So all those kind of tests, like your algorithms are also working with the nodes. So all those kind of tests will be integration test. And then next layer of test will be the component test. Why it is important? Because let's say Parveena explained there are various components like perception, where your data will come from sensors or other hardwares, right? And you can test the complete perception system. After perception, there will be system like planning or navigation, where your machine will decide how to navigate and all. So those components you can test separately as whole component, and we can mock rest of them. So we will see how we can mock, and what other type of testing are available under that. And after that, another important testing is testing on the simulator. It is very vast. Various types of simulators are available. It's not only software simulator, any other kind of simulator like hardware simulators are also available. But and we will see in the upcoming slide what is the difference between testing just a component or testing on simulator, because you will be thinking like if we can mock any component, then we can test other component easily, right? And in simulator as well, there will be no hardware. So what the difference will be in the simulator, so that you will come to know in few minutes. So this is brief about, like in normal projects, we test like this, and here also the basic quality concepts will remain same. And of course, performance, security, safety testing is very important in AV, and it will go from level 1 to the higher level. Like level 1 we call unit test in ROS, and there can be any higher level of testing. So performance should be tested at every layer, because basically you are not deploying uh, any artifact on any server and all. So performance is really important, because they are very different type of hardware where your software will be running. So performance security is very important. Yeah, this is brief about different levels of testing. And since you guys have said you haven't worked on AV, so I assume you have worked on other kind of applications like web and mobile. And here we have just mentioned like what I noticed when I joined this AV project. I was also working on web or mobile based project before. So what I have seen is how it is different in terms of testing. First of all, AV software are deployed on specific hardware, and we'll have to consider whenever we build whenever we build a software, even we will have to consider, are we taking any variable with large memory unit or small memory unit, what is the range. So all these minor things will always matter when you are developing for particular hardware, right? ECUs are electronic control unit. In a car typically there are more than 50 ECUs, and in luxury car you will find even more than 100 or 150. And when the level of AV will increase, the number of ECUs will also increase. And second, of course, heavy computations in milliseconds, because let's say there's some object in the surrounding or in the front of vehicle, you will have to apply sudden brakes. Let's say your vehicle is moving with the 100 kmph, and then you can assume how quick that decision will be required. That's why C++ is getting used a lot, because it has capability to handle the memory storage in a nicer way as compared to normal garbage collection, right? So that's why tech stack is very important in AV. They are limited tech stack. It's not like we can use any language like JavaScript or anything. Okay, and the way data is shared, it depends on the middleware. So here we have taken an example of let's say ROS. So ROS works on the TCP, and data is shared using ROS topics. Someone will have to subscribe to that topic, then they will be able to get the data. Okay. So this is the minor difference, but of course I agree, like complete architecture is different, but in terms of use, let's say when I QA test, then this is the main difference you will have to think. Okay, so basically, like you have seen while testing, there will be a lot of different kind of framework, right? Test ng, JUnit, and unit. For C++, gTest is quite famous, and it is almost similar to other framework. Like this is the simple syntax. you write a test, and then the common kind of assertions like expect equal, greater than, or not equal, whatever. So these kind of normal assertions you will see in the gTest as well. And it works on these OS and works with C++. So it is very common actually. Let's move to the demo part.
Before that, Lovely, just a quick poll around if everyone is understanding the content and everything. So I'm just launching a poll currently. Yeah.
Thank you for reminding me. Yeah.
All right, people. Answers awaited.
So there are two open questions. Probably someone can reply. So 87% people say yes, we are going good. Okay, so it means speed is good. It means we can cover as much as content we have for this talk.
Yeah,
that's good.
keep going.
Yeah, so Pravina has mentioned about README steps and all, right? And she has explained like how to run the nodes, right? So we have one publisher which is publishing over the topic one and sending some data, and subscriber is receiving that data. The code is very simple. You can see a lot of comment that is for your understanding, and we have taken reference from official ROS website. So this is just for your help. Otherwise, lines of code is just 6-7 lines in the complete file. Okay, so let me show you the gTest, how the tests are written. So in SRC, we have the source code. In test, we have the actual unit test. Okay. So test publisher, what it will check is basically what we should check. So first we should check when we start the node should be running. It should not stop. It should not exit unexpectedly. So it should be running, and it should be publishing the topic, that is topic one, right? So this is very basic test. Node is running, and it is actually throwing the details, I mean sending the data over the topic one. And similarly, subscriber will always have similar details, like a subscriber is running, and it is subscribing to the topic, that is topic one. Okay, but based on because in this tutorial, in this talk, we will not be able to add each and every type of test. So basic tests are added. That looks quite similar to any other testing framework. So here we are using gTest and C++. Some part of Python is also used, but for now you can ignore. We will come to that part later. Okay, so how do we run the test? Pravina has explained like we can first build our system using make. So I'm also building, and then we will be able to run the test as well. Okay, so it has built the target, publisher, and subscriber. Now we have to run the test. So command is very simple. It's mentioned in README also everywhere. Make run test is the command. So it is still running. Now it has completed. Okay, so running the test is very simple. You can see the summary and all. You can see the name of the test and all, and also you can see the report as well, because we are not using any reporting in this talk. We are using default reporting for gTest, and where you will find the report under build directory, go to test result, and under test result you will have the package name directory. Our package is ROS demo. Basically, in what happened in actual project, so when you create Catkin workspace, there are a lot of packages, but in our case we are using just ROS demo package. Okay, So we have only one package. Otherwise, cat key make will compile all the packages, and cat key make run test will run all the tests of all the packages. Okay, so this is useful. Yeah, so under build test results, we will have these XML files, which we can view to see tests are running fine or not. Like we can see some kind of report. But yeah, of course, there is since we are not using any reporting, so this is how the reports are generated. Like for each test, there will be some kind of report, like, and there will be errors as well in case of any failure. So running the test is quite simple, and it is as per our testing strategy. This is level 1 unit test, and if we start both the nodes and then start in testing the interaction between those, then it will become sort of nodes integration test. And in this talk, we haven't written any algorithm. Otherwise they will be testing for those also. But those will be basic algorithm, like you like people write in any language, and this testing each and every function of the algorithm. So our focus is on ROS, and one thing I want to mention is we don't need to test the ROS. ROS is already middleware. We will not test like data is getting lost or not. It will we will not assume that. So we will assume that data, if we are someone is sending, then if we are receiving, then it will come in the good same format. So we are not testing the functionality of ROS. We are testing whatever we have written, like subscriber, publisher, all these things, and whatever the algorithms. But practically, if you see, here we have the nodes under, yeah, under lib we have the nodes. But practically, people will not be running each and every node, right? Because we will have 50 nodes at least in a project. So another way to run the node is we will also see. Till now you have seen 2 nodes, right? Just ignore the test publisher because this is just for the testing part. Nodes are just publisher and subscribers. Okay, so right now one way is to run using that, using just // executable name, but this is not the ideal way. So what we do is we create launch files. Okay, under the launch you will find some launch file. You can name it anything, but it should be syntax should be okay, but you can name it any name. So under publisher.launch we have said like just start the publisher node, and under the package and type you can give same as name. Okay, so package is ROS demo, like we know, and publisher is name of the node. So it means we can start node from catkey folder. Even we don't need to go into dwell and lib. We can just say ROS launch package name, that is ROS demo, and then just press tab. You will get the launch files in launch files, and this is one of the launch that we can run. So even we don't need to start ROS core manually, so it will start automatically. So now you will be seeing ROS node is running. See, publisher is running in the ROS node list. Yeah, these are the advantage actually. So we don't need to rely on running it manually, and it is not only one node. You guys can run any number of nodes, like whatever is required for the project. I have seen in projects where we have big hierarchy of launch file, and we are running more than 30-40 nodes using one launch file, and it is complete modular way. It's not like you will just copy paste number of lines. So like one launch file can have 5 nodes, and inside that there can be multiple launch files also. So it's a very good way to initiate the nodes. All right, so this is about running test and starting the nodes using launch files. And here you have seen, just for the demo purpose, we are sending the data that is hello world, right? But in actual, do you think like we will be sending the data like that? Sorry. Where is the data?
Line number 64.
Yeah. Okay. So here we are just sending the string message. But in actual world, there will not be any string message. There will be very complex type of data, and it can be anything, like it can be very large sensor data or camera data or whatever, in the form of numbers or in the form of strings, whatever. So the main problem we see in this kind of project is how we actually prepare the test data, and how we visualize that test data, because creating the test data is one thing, but visualization means you are able to see that data, because data doesn't mean it will be 2D data, or it can be 3D data as well, right? So we will be able to see the 3D data as well using some ROS tools, but first of all we need to understand what kind of data we need and how to create that. Okay, so since ROS is not only a middleware, it has a lot of libraries, right? So since we are creating the data, so first we need to understand the type of data, right? And let's say if you are using some libraries, ROS navigation stack, just for the, so that our vehicle can navigate, and we can use a lot of different packages in the ROS. And as per this document on wiki.ros.org, it says for navigation stack, these are the inputs, like sensor data, path, whatever is the goal, and then outputs are, it will move the machine with some velocity or speed, acceleration. But for that, how will we create the input so that we can test the complete component? Okay, so we are talking about the component testing, and even for integration testing as well, sometimes you will need data. So mostly it will be used in component testing, like navigation component. And here, let's say I will take one example, that is path. So path is basically, it is not like a simple path, since we are using ROS. So we'll have to rely on the ROS message type. So if you see here, ROS has standard messages. Like if we go back, nav messages means navigation messages, and under navigation messages, it has lot of messages. So let's say each and every message has message type. Like for example, 1 to 3 is a number, hello is a string. Similarly, in ROS, this message has some type, and then we will explain what type of data, what kind of data we have to create. So first of all, just click on the message type. You will land on the page where you will see the definition, and under definition it needs header, it needs some array of pauses, right? So we will use this kind of information, and then we will create the data using Python. Okay, so just remember two things. It need header, and it needs array of pause temp. That variable name is pauses. Okay, so just remember these two things only. This is what path needs. And now I will show you what data we can create for this path message type. So under test, we have data create path data.py, and we have created a very small function, create path. This is like a few line function, and it is creating the path in the same format what ROS rely on, right? So we are creating path object, and since you have seen on the web page, what path need is, it need post temp array, that is we are appending in a for loop, and post temp, and other than that, what it need is, it need header. So we are using path dot header, some headers and some post temp also. Don't try to get in detail, but let's assume that whatever data type is mentioned in the official document, we will be using same format while creating that. Okay, so we are appending post temp because it was mentioned like it need array of post temp. Okay, and further, if you want to see what is post temp, then just click on that. Now it will say it need a pause and it need a header. Header is sometimes optional, but let's focus on the pause. So how we are creating the post temp? So we are creating the post temp with the pause. Create post temp, we are creating with the pause. And now you will be surprised how pause is getting created. So just click on the pause. It will show you what pause has. It has point and quaternion. So variable name is position, that is XYZ, and orientation means the direction of the direction where the path is heading. So let's say in the north, south, or whatever angle. So we created point, we created quaternion, and then using point and quaternion, we created pause. With pause, we created pause stamp, and pause stamp we are appending in the path just to get the path. Okay, so this is quite simple. Like when you will be familiar with the message data type, how it works, you will be able to create that. And a lot of online resources are also available if you find some difficulty. So we are just using some libraries, Python libraries, and when you install ROS melodic or any version of ROS, then it will automatically comes with that. So we haven't installed anything else. Okay, so and the benefit is, let's say, so we have created one function, but with one function you can create any number of paths. So it is taking input as coordinates, like xy coordinates. So let's say we have given coordinates as input, then we are just calling create path using coordinates, and here we are creating the path, and I will show you the output as well, right? So we are just giving input to the function and it will create the path. And how it will create, we are using some utilities. If you have already seen, after creating the path, we are just calling this function as well, write data to YAML file. So it takes the path as object and it write to the YAML file. So it's very simple. Write data to YAML file is just a very small function. So we can create n number of paths using this kind of code. Even you can make it more easier as well. Let's say if you want data for a complex path, or if you want data for a large path like circular path, you can, instead of writing coordinates, you can just write mathematical equation of circle. It will create the coordinates automatically, and then with the coordinates you can create path. So it depends how you want to handle. So as the project grow, we try to make the process as simple as possible, like nothing manual, just everything should be automated. Okay, so the way we run Python is quite simple. So here, let's say, here we have create path data.py, and we can run this Python file. Just write Python and create whatever the Python file name, and it will create the data. So it is creating data for shape 1, shape 2, shape 3, whatever I have mentioned here, like shape 1, shape 2, or shape 3. Okay, and under data directory, it is creating data. You will see this kind of YAML. So this YAML is basically the format that ROS understand. Shape 2, shape 3, right? So if you have any doubt till now, feel free to ask. And if you have any doubt regarding coding part, because first time you will of course not understand, it's not very straightforward, because people need some knowledge of libraries and coding, whatever they are using. But it is normal, like if you are doing any sort of automation in your project, then you will understand these things easily. Okay, so this is how the path looks like. But still, the problem is not resolved. Creating the path was simple, but now we have to visualize the path, right? Because sometimes path can be 2D and sometimes it can be 3D, and it can have path of maybe more than 10,000 lines or 20,000 lines. Then it will be difficult to check what this path is for and how it looks like. Okay, it can be a path data, it can be sensor data, it can be any velocity data, position data, it can be anything, right? So next problem is basically we are going to solve is how to visualize the data. Okay, so visualize the data is also simple. We don't need to use any external tool. We can use ROS tool, that is RViz. It stands for ROS visualization. And with this tool, we can view any sort of data that is supported by ROS, like laser scan data, camera data. You can see various displays. It's a display name, description, and message type. So if the message type used is in any of the message type listed here, then RViz will be able to display the data clearly. But if let's say if we are using our own message type, then we'll have to write our plugin. But it depends on the need. Sometimes people can use standard messages, sometimes people can use custom messages if some functionality is not covered in the standard messages, right? So it depends on the functionality. But I will show you, I have created the path that is a standard message. And yeah, let's see that how we will display. Okay, but before that, I will stop my launch file so that no node is running. Let me check if any node is running or not. Yeah, publisher is still running, so we can just kill that. Yeah, so any other node is not running, just ROS master is running. That is, you can see by ROS out. Whenever ROS out is running, it means ROS master has started that. Now we have to visualize the data, right? We have created the data in YAML file, just to visualize that. So before that, we have to start the RVs. RVs can be started by just one command, that is RVs. So it's a cannot contact. So it means there's something wrong. We'll have to start ROS core again. Yeah, because earlier ROS core was started by the launch file, so that's why it had some problem. Now ROS core has started. Now I'm running RVs. ROS core basically start the master node, which is main node through which the communication will happen. So this is how the RVs looks like. Okay, and now we have to click on the add button to add the display. If you want to use any particular data type, then we'll have to add accordingly. So there is a display with the word path. So we have also created the data for path. We'll add that. And here, if you click on that, at the bottom side, you can say it display the data for nav messages path message. Nav message path is the what we were seeing in here, right? So this is what we have created the data for. It means these data types are same. Now we will be able to visualize. How to visualize? How does it work basically? So RVs will basically subscribe this message type using some topic name. Okay, and it means someone will have to publish. In ideal world, what happen, like when the sensor and everything is working, then data will be coming from those sensors and all. But right now we don't have any sensor, so we have created the data and now we have to publish manually. So in the README, you will find the commands to publish the data. Yeah, so follow below steps to visualize data. We have started RVs and now we have to publish the data. So I'm just using the command ROS topic, publish any topic name. You can use any name, and then type of the message, that is name message path, then -f, and then file name. Okay, so I will just copy paste this command. You can also try later on. Okay, so first of all, I will have to go to the path where this data files are stored. It will be in the test, I guess. Yeah, so under test, we have for test data scripts, and under that data, where we have mentioned the path. So under data, we have various data YAMLs. So I will choose any one, that is shape one. Again, see, this is ROS topic publish is standard command. Pub means publish the data. And this is topic one is name of the topic. It can be anything because we are not publishing the data through any node. We are publishing manually, right? So, and then type of the message, and then -f, just name of the file where the message or data is stored. So this is now we have sent. Okay. So it's a got one message and a rate publishing repeatedly. So by default, it repeat automatically at 10 Hz rate. It means multiple messages even in 1 second. And now in RVs, we'll have to told on which topic it will have to subscribe. So we'll have to select topic 1. Okay, now we will be able to see the data, right? But right now also we are unable to see, maybe we'll have to zoom in or zoom out. Yeah. So this data, we can see that is any irregular path that we created using Python. Sorry, my controls on Mac are not working properly. Yeah, so this is very random data path. It's a 2D data, that's why it looks simple, but it can be even 3D, then even RVs will be able to display. So now it has displayed the data. So this is how you can validate how does your data looks like, and then you can feed in your source code, and then you can start testing. Okay, but like I said, RV is subscribing to that topic, but how will you believe that it is subscribing? One thing is it is written also, it display the data from name message path, but another way is to check from command line tool. So I have a lot of terminals open, so I guess bottom one is free. So just use ROS topic list. It will give you the type. So it will say all these topics are running. Let's say topic 1 is our topic, and then just write ROS topic info. This is standard commands. You will find everything in the readme. Topic 1. Now it will show you what is the type of the message this topic is publishing, who is the publisher, that is ROS topic command. Otherwise, if it is published by any node, then you will get the node name as well. The publisher is our ROS topic command, and subscriber is RVs. Now it's clear that RVs is subscribing. That's why RVs is able to display. And other display, if you want to see, like grid cells and path, laser scan, sensor will always be here, of course, temperature. So whatever you can think about, any type of those message data, you get it. And of course, by topic as well, you can select. So this is topic. A lot of functionalities are available in those. This is quite a basic one. You will see a lot of controls. We can even, let's say, want to create some path. Then we'll have to create our own plugin as well if you want to use some advanced functionality. But this is basic. I can see a few chat messages. So if you have any question, please ask in Q&A. Moving back to the PPT part. So visualization is now done, and after that, sometime what happen? Let's say you have any path, and you have any map, let's say, and you have to find the shortest path so that your algorithms, your vehicle can move across that path. But who will find the shortest path or whatever easiest path? Your algorithms that you will write in your code. Okay, but sometimes what happen? These algorithms are very complex. Let's say this is the green is the start node and red is the end node, and there are a lot of obstacles, and your algorithm is written in such a way that it will avoid the obstacle and will find the path. Then that path, by looking at the map of very large size, you cannot predict your algorithm is giving you the shortest path or not, right? Because it can have large number of paths possible. You cannot just check the map manually and visually and see your algorithm is giving the data correctly or not. It is not, and even you cannot automate that thing very easily. So you will have to rely on some kind of source of truth, right? So how we do validation of our algorithm? One way is if it is not possible by manually. One way is to rely on any standard algorithm library, and another way is to rely on any other source of truth. Like for this algorithm, we found this reference useful. Like let's say if I draw my path anywhere, and if I add any obstacles in between, and if I start searching, then it will give me the path which is shortest path and avoiding the obstacle as well. Right, so I will rely on any standard source of truth or any library that is available. And then I will compare my code against, I will compare my test results, or you can say output of the path with this output, right? So this is one way to validate, but in normal applications, it's very easy. Like if you're in web application, you can see page is getting displayed, whatever. So that you can verify manually, but sometimes you cannot verify manually. Yeah, this is how you validate algorithms. But till now, we haven't started working on simulator, right? So you have seen we can create the data whenever it is required. Like for navigation stack, data were required, we created. But if you notice, we are creating the data, and it is also time consuming. But in real world car, data will be coming from sensors automatically, and then your system will respond. That kind of testing is very easy, and you will need actual machine for that testing. But before moving to actual machine, and after doing all this kind of testing, like whatever we covered, there is a testing in between in between real machine testing and in between unit testing. That is testing on the simulator. Okay, so how the simulator works is basically it not only mock the data, it basically have some physics engine. So like you play the games, some any person or any human being is moving, and that person, let's say, fell down somewhere, and then the way that human interact is like normal human, right? Because those gaming engines or those simulators have some physics system, like rigid bodies, soft body dynamics, fluid dynamics. So those simulators will have physics engine, and it will behave like a real object, real machine or real human being. So that's why the use of software simulator in this robot industry is quite famous. And but we'll have to do a lot of work as well. For example, if we have a lot of sensors and hardware on our machine, then we'll have to simulate. But the good thing is it will be simulated software only. So even you can run these things on any cloud machine, on any machine in your whatever is machine given to you. So you can run on that Linux machine as well. So no hardware is included. You will have to create all the graphics like map where your machine is moving and various components, object, obstacle. So all these things can be simulated using any simulator. Okay, and how will it work basically? So let's say this is your AE software. So you will send the message like path and all. It will be first time only. You will send the data like where you have to go. It will be actually like your ROS nodes, your algorithms, whatever. It will be a complete software. And then simulated vehicle model, which will behave like a real car. It will get those data, and then it will get the surroundings of the vehicle by whatever the world you have simulated. Accordingly, it will get the sensor data and everything. Though everything is simulated, but it is simulated with the physics system, so it will behave like the real. And then based on those surroundings data, it will move the machine with some speed. Okay, so and this will also be some kind of ROS messages, and then your software will consume that, and accordingly the flow will continue. So this is how it works. Okay, so it's not like, let's say your software say your path is very away, so let's start the machine with velocity 20 kmph, but suddenly some sensor data comes using your surroundings, using vehicle model, and then it will slow down the machine, and then whatever the output it will give will be input to your software. So now it will say your speed has been reduced, then accordingly send the further commands. Okay, so this will continue, but in real world, instead of this simulated vehicle, there will be real vehicle. This is the difference. Otherwise, everything is same. Any doubt? Any questions? Why we are using simulators? Okay, and of course, because these are simulators, software simulators, and we are creating a lot of simulations use of sensor and camera, so it will be quite heavy software, and you would need some real machines that have Ubuntu OS. Sometime on VM it will not be able to perform well. You will need GPU as well. That will be useful to show the graphics and do some processing. So this is how the ROS based simulator works, but there are a lot of other kind of simulator also that we will discuss. But ROS simulator means like the data flow. It will be in terms of ROS messages. And of course, we will have to use various ROS libraries for the communication purpose. And this kind of test, good thing is you can run in your pipeline as well. In some kind of sanity test you can prepare, and it will be running after every commit, or after, let's say, once in a day or twice in a day, because it will take few minutes of execution time. Yeah, that's we have seen this kind of test in our CI/CD pipeline. Okay, so if you want to try Gazebo, that is one of the ROS simulator. You can try few of the references. Let's say I found a lot of good references online, and you can check using Python and C++ as well. Like you can create your car object, and it will be moving across some path. That is some kind of simple simulator, because right now you don't see any object, anything. But when you keep on adding object or real conditions, then it will become more complex. Okay, but at least this kind of test we would encourage to have in the as part of pipeline, or to run very frequently. Other references are also attached. Few of the references are based on Python, or few are based on C++. This one is also good if you want to try. Here also a lot of details are mentioned. They are using some complex system like Docker. They're using NVIDIA as well. So a lot of simulators are available. We will see in the upcoming slide. Okay, so these simulators are 3D simulator because we can create the 3D object. So what we have talked about is ROS based simulator. Gazebo is one of the ROS based simulator that is free and open source, and it's has good community support. Other software simulators are ROS based, or it can be even any other middleware supported system as well, right? But nowadays lot of different simulators are available that are based on model based, like you can write your ML model and you can train based on the data. So you can try exploring these links as well. We have attached in the PPT, or we'll see if we can share these links with you. Okay, but of course you can watch the video, and then here you will get the names of the simulator. And another simulator we found is quite interactive is Unity based, because Unity is a gaming engine, and gaming engine also has some physics, right? So Udacity simulator, this is also have Unity engine, and this is also a good one. And here some kind of tutorial is also given for this kind of simulators. NVIDIA Drive is also another good one, and so you can see this is actually some complex system. It's not very straightforward. So you can see real looking road network, but it is not real. So but you will be able to test everything. Like for example, this is your second vehicle is your vehicle running. So what it perceive, like what it get from the surroundings. So you will get to know all these things in the simulator as well. So because testing on the actual vehicle is very costly, so this is very useful. A lot of companies are working on building the simulator. Okay, so till now, whatever we have covered is just on the software part, right? But since the product is made of software plus hardware, and next level of testing that will be covered will be on hardware simulator. And of course, since it is hardware simulator, then we would need different kind of hardware for the testing. People will have to set up some maybe hardware in low bench, maybe some kind of lab. There we will have some hardwares like ECUs and different kind of high processing unit, so that we can test various things end to end. Like for example, you have to test the sensor data. So sensor data, it will be coming from the surrounding and then it will be processed. Okay, so right now whatever testing we have done is on our system, on some system like with very good processing speed. But this software will be deployed some ECU that has limited hardware capabilities, right? So if you want to test exactly how your hardware will behave with the software, then this is one of the reliable testing in terms of performance. Okay, and this is what we cannot do very frequently, because you will need hardware as compared to software testing. And here we can test our camera, sensors, radar, everything can be tested. And of course, your ECUs, electronic control unit, will be used where you will deploy the software. Okay, so till now we did not deploy our software. Only in hardware simulation testing we are deploying our software to some electronic control unit. So that can be done as part of hill testing. There are a lot of use cases, like not only in the automobile, like aerospace, or in ADAS system is quite famous, like in Mahindra XUV 700 also it came. So those kind of features can be tested with hill testing. Okay, and you can see like DSpace hill simulators. So various companies provide simulator, but DSpace is one of the company that is we have taken the reference for hill in this talk. Okay. All right. So after unit and other testing, we talk about simulation, right? But in simulation, how will be the testing strategy? So first, people will start with the software simulator like Gazebo or Unity-based engine or whatever. This is how we will be working on easily software simulator. And then comes data replay testing. Data replay testing is also including some hardware. You can see in these pictures, right? So it means like, let's say you are driving in the real conditions, and you get the data from your real vehicle, because let's say your real vehicle is moving on the road. You will get some data through the sensors or cameras or lidars. You will collect that data. A lot of tools are available for collecting the data and then processing the data, and then using some hardwares in loop software, you will use those data get processed. Okay, and then that data will be using for the testing purpose. So it means we will not get data from actual hardware. We will get once, but we will store it somewhere and then we will replay. So that is it called data replay testing. It needs some kind of hardware. It's not completely hardware in loop, but hardware in loop testing involves a lot of hardwares like ECUs and other high processing units that can simulate other part of the system as well. Let's say if you are testing not the complete vehicle, you are testing one component, you have to mock other. So for that, you'll have to use some hardware processing unit. So for that, this DSpace company is one of the company that providing hardware simulator. And after that, we will move to actual vehicle testing. If we are satisfied with every type of testing, then final testing is vehicle testing. All right, I think we are done the content. So now we can take further questions if people have, or if you have any doubt, if you need to repeat anything.
Also, please take some time to provide your valuable feedback.
Yeah, right. So link is shared in the chat section. You can fill that. And GitHub repo, let me share that.
Yeah, I have already shared in the chat.
Okay.
I'm sharing the link of the YouTube channel as well.